If filters make results feel wrong and facet counts look broken, we'll build faceted search the right way in Whoosh fast filters, stable relevance. You get messy search results when filters and sorting fight relevance. That frustrates users and hides good items. By the end, you will understand how to index fields for faceting, apply fast filters, keep facet counts correct, and combine sorting with pagination so browsing stays stable. I'm Professor Pi, teaching search and IR with simple Python. Faceted search solves a common web and internal search problem. People search with free text and then narrow results by category, date, tag, or numeric range. If you do this poorly, counts lie, pages jump, and relevance feels inconsistent. Whoosh is a lightweight search library for Python that handles indexing, scoring, and faceting in process. It fits well for catalogs, documentation, and small to medium collections where you want control without a heavy external service. Think of faceted search as two things working together. First, a full text index that ranks matches by relevance. Second, a small set of categorical or numeric fields that you can filter or count over. The index gives you matches. The facets let users refine and explore. Strengths are quick development and transparent behavior. Weaknesses are that for very large datasets, a dedicated service may be faster. We will build a tiny Whoosh project. We will define fields for text, category, and year. We will add a small dataset, run searches, then apply a filter while computing consistent facet counts. Finally, we will sort by year and paginate. This will make filters, facets, and pagination behave predictably. This snippet creates an in-memory Whoosh index with fields for text, category, and year. This snippet shows how to declare a schema, so Whoosh knows what to index and what to store. It defines a text field for full text search, a keyword-like field for category so values can be faceted and filtered, and a numeric field for year so you can sort and range filter. The snippet opens a RAM-based storage and builds the index writer. It emphasizes storing the original values so results can show the title and year without reloading external data. The key knobs are field types and whether they are stored or just indexed, because those choices determine what you can sort and display. Now we'll add documents into that index. This snippet adds a tiny dataset to the Whoosh index for later filtering and faceting. This snippet shows adding a handful of documents, each with text, a category value, and a year value, and then committing those documents so the index can be searched. It demonstrates calling the writer add document method for each item, and then calling commit to make the changes visible. The important detail is that the category values are consistent across documents, so faceting will group them, and the year field is stored as a numeric type to allow ordering and numeric comparisons. Adding more documents follows the same pattern and is safe to batch before committing. Next, we'll run a simple text query and look at top results. This snippet runs a basic Whoosh text query and inspects top-ranked results. This snippet shows creating a query parser against the text field, parsing a user term, and executing a search to retrieve the top matches. It walks through opening a searcher, running the parsed query, and then iterating the results returned in ranked order. The explanation highlights that Whoosh uses a relevance scorer, so results come back sorted by match quality by default, and that the search call accepts a limit to control how many top hits you retrieve. If you increase the limit, you see more candidates. And if you tune the scoring parameters, you change which documents bubble to the top. Next step, apply a categorical filter and compute facet counts. This snippet filters with a Whoosh term and returns consistent facet counts by category. This snippet demonstrates wrapping a query with a filter that restricts results to a single category term, and at the same time collecting facet counts so the UI can show how many items are in each category after filtering. It explains using a term filter, which is a fast exact match on the category field, and then using Whoosh's facets collector to compute counts from the filtered results set. The key idea is to run the facet counting in the same filtered context, so counts reflect the active filter instead of the entire index. Changing the filter value will naturally update counts and visible hits. Now we'll sort by year and implement pagination for stable browsing. This snippet sorts results by year with Whoosh and paginates for stable browsing. This snippet covers performing a search with a sort key set to the numeric year field, and then retrieving results by page offsets, so a user can move through result pages. It explains that sorting by year produces a deterministic order which prevents items from jumping between pages when the user navigates, and that pagination uses an offset and page size to fetch a slice of the sorted results. The paragraph notes that increasing the page size reduces the number of page requests, but changes user memory, while smaller pages make navigation snappier. Combining sort with filters ensures a stable experience. Mapping this toy example to a real project is straightforward. Use the same pattern for product catalogs, document libraries, or support articles. Keep catalog fields you want users to facet on as simple keyword or numeric fields. Store display values so search results render instantly. For larger collections, you can move from in-memory to file system storage, or swap in an external search service while keeping the same indexing logic. Recap. Faceted search pairs full text ranking with fast field filters and counts. Use it when users need to explore and narrow results by category, date, or tag. One caveat: ensure your facet counts are computed in the same filtered context, or the UI will mislead users. Next step: tune BM25 parameters K1 and B to better match your relevance needs. Then measure how that changes top results and user satisfaction. If short, practical information retrieval helps, subscribe and watch the IR videos.